Well, hello, everyone, and welcome to another episode with your girl, Audrey Codner from ACG Math Tutoring. Hopefully, you guys are doing well in this lovely, nice little fall-ish weather that we're having here in Baltimore. So, hopefully, you guys are getting yourselves ready for maybe some exams are coming up. Some people, their midterms are coming up, especially the college algebra people. Hey, interims are right around the corner. So everything is coming ahead. So what I am going to be doing today is breaking down two concepts, which is going to help you with one overall concept. So instead of me just coming here and say, yeah, let's do rational functions, and some of you guys are still struggling with the exponents or even factoring, I decided let me do those two first. So we're going to work on exponents, then we're going to work on a little bit of factoring, then I'll come on later on today, possibly tomorrow, depending on how things are going, and we're going to work on rational functions. All right. So if you need help with GED, I know people are going to say, is this in the GED? Yes, it is. So that tells me you haven't been doing too much studying, because you would have easily seen that exponents is in GED, ASVAB, ACCUPLACER, SAT, ACT, HES, what is it, HESME or HESI, the TEAS test, basically all of them deals with exponents. So let me zoom in as you guys are coming in so you can take a little bit of the notes and maybe even just take a little snapshot or two. You know, why not? That's why we're here. Don't do a little bit of learning. All right. So good morning, Addicted. How are you? Jordan Square. Hello, happy Saturday. All right. So exponents. This is the key. All right. The whole entire thing is called a power. Now, the larger number at the bottom, that's your base. The smaller number expended in the top, that is your exponent. Your exponent's job is to tell the base, hey, base, what's up? I need for you to multiply yourself 3 times. Okay, so that means the base has to go 5 times 5 times 5. So it's not 5 times 3. Okay, the 3 is smaller than this 5. It's a little small in stature. Okay, we still love it. You know, we love our short kings. But this 3 is telling that our base is multiplying itself 3 times. So 5 times 5 gives me 25, and 25 times 5 gives me 125. All right, this is how you're doing your exponents. Okay, so when we're taking a look at this, hello, Michael, how are you? When we're taking a look, there are certain properties that we need to deal with. Okay, so the certain properties, different colors, different properties. So the one, let me see if I can zoom in a lot bigger, and I'll just take it slow. So the first one is when the product property. So when you're multiplying, and notice they have the same base of A, you are adding the exponents. So we had a problem like this yesterday. And a lot of people are like, wait, how did you get that? Because of the properties of exponents, when they have the same base and you are multiplying, you can add your exponents. So if there are different bases and you're multiplying, guess what? You can't add your exponents because your bases are not the same. Similar is going for the quotient. Okay? With the quotient, you're dividing. And when you're dividing and you have the same base, notice the base is A, you are subtracting your exponents. You start with the exponent in the numerator and you subtract by the exponent in the denominator. Okay? So then you're putting that inside. So you keep that base, but you're going to subtract the exponents. Okay? So with the multiplication, you add the exponents. Division, you subtract the exponents. So if you want to think it this way, multiplication, you're usually making things bigger at a faster pace. In addition, you're also making things bigger. Not so much at a fast pace, But that's what it is. Remember, multiplication is just fast addition. There you go. So for division, you're going to subtract. When you divide, you're usually making things smaller. When you're subtracting, you're usually making things smaller. But what happens if you subtract and you get a negative exponent? Well, you can't just leave it, okay? We all like to have our exponents to be positive. So when you have a negative exponent, you're going to have to do what's called flipping, okay? I know, it's really deep. So here we are. If we have a negative exponent, we need to drop it into the denominator. The act of dropping it, because remember, anytime you have something as a whole number, you can put it over 1 to make it as a fraction. To negate this or to make this negative into a positive, you're going to flip. Okay, so it's going to drop down here in the denominator, and then you have your 1. Okay, but what happens if the negative is already in the denominator? Well, then, baby, you flip it. So when you flip it, now the a to the n is going to be the numerator. The 1 will be in the denominator, but we all know anything divided by 1 is self. All right? So we come into all this. You include the original 5 too. So it's basically 5 times 4? No. Okay? If it's 5 to the third power, that means this is what your teacher's trying to say. So when we have 5 to the third power, the first digit is going to be your base. And then you are multiplying itself 3 times. Okay, so it's not going to be 4. You're adding an extra 1. That's what's wrong. You should see the number. If I have 3, I should see 3 5s. If it was a 4, I should see 4 5s. Okay, if it was a 12, I should see 12 5s. Okay. All right, hopefully that cleared it up a little bit. All right. Yep, that's why I'm doing it. That's why I'm doing it. Okay, so power of a power. That means if we have an exponent being raised by an exponent, and there's a separation of a parenthesis. The reason why this parenthesis is here is saying everything inside of this parenthesis is being raised by this exponent of y. Okay? So when we don't see a parenthesis, like if I said, we're going to see some examples. I just want to go over the properties first. Okay? But when you see a power being raised to a power, you're actually multiplying the exponents. That's what that xy is. Okay? You keep the base, but you multiply the exponents. All right. Okay. I'm going to get to the example soon. Keep your panties on. All right. So, power of a product. So this is when you have something that's being multiplied inside the parenthesis. Everything is being raised to a power. So that means the A is being raised to that power and the B is being raised to that power. Okay. So then we have our power of a quotient. So again, we have our fraction and everything is actually being raised to that x power. So that means the A is being raised to the x power and the B is being raised to the x power. And the most famous one that everyone gets wrong is anything raised to the 0 power is not 0. Stop it. It has to have, everything in the world has to have a start. Okay? So when anything that's raised to the 0 power is equal to 1. Okay? So one of these days, quick story, I had one of my college finals, and this is when we had blackboards. I know some of you guys don't even remember what blackboards are, but work with me. And this blackboard was the whole entire length of the, there you go. It was a whole entire length of the front of the classroom, and it continued all the way well, halfway through the length of the blackboards on the side of the room. And it had fractions, it had decimals, it had square roots, cube roots. It was ridiculous. Everyone looked at it and he said, "This is your problem. This is your final." And we all looked at it like, "Oh dear God." But I noticed there was a bracket at the beginning. And then, I wasn't like the sharpest person in the world, but I noticed there was a bracket at the beginning, and then I followed it along, and I was like, all right, so where's the end bracket? And I noticed the bracket was at the end. And that whole entire thing, whole length, everywhere, all the way through, it was raised to 0 power. So the answer was 1. My friends were sitting there struggling. We were supposed to go out, get a little snack afterwards, like a little celebratory thing. And I was sitting outside waiting and waiting and waiting. And then my friend Jen comes out and she's like, she's from, Jersey. And she's like, "Oh my God, how'd you get done so fast?" And I'm like, "Dude, the whole thing was raised to the 0 power. It's equal to 1. And she's like, "Oh my God." And then so she tries to run inside, and then I went to get food for myself. So, like the story is, anything raised to the 0 power is equal to 1. No matter what's going on inside, if it's all the way bracket, then it's all the way bracket. So we have 5 squared times 5 to the 6. All right. Okay. All right. So now we have 5 squared times 5 to the 6. We have the same base of 5. So that means since we're multiplying, we are going to add our exponents. Okay, so that means this is going to give us a solution of 5 to the 8th. Okay, not 5 to the 12th. Okay, not 3 because we're not subtracting the exponents, we're adding them. Okay, so when you multiply, you add your exponents. So let's try this one. So we have y to the 4th times y to the 3rd times y. Okay, what's my answer? Is every number to the 0 power besides 0? Even 0. Everything raised to the 0 power is 1. Everything. Okay, so Michael, we're saying y to the 8th, y to the, let me back up. Serena is saying y to the 8th, Agent of Gods, y to the 6th, J Wolf, y to the 8th. I got you, Michael, with y to the 8th, Heather, y to the 8th, and so y to the 8th, Janie, hey, y to the 8th, bye, Felicia, y to the 8th, Lisa, y to the 7th, y to the 7th, Rivera, y to the 7th, okay, y to the 7th, y to the 8th, okay, y to the 7th. So we got y to the 7th and we got y to the 8th. Okay, y to the 7th, y to the 8th. What's missing? Okay, we have a mixture. What's missing? Okay. Okay. Yes. There is an exponent right here, guys. There's an exponent that's understood to be there. So yes, you add the 4, the 3, but there is this extra y. Okay? This is y to the 1st power. So anytime you don't see an exponent, there is an exponent of 1. Okay? I know a lot of teachers will say, oh, y equals 1. No, 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 no. the coefficient or the number in front of the y equals 1, as well as the exponent equals 1 when you just see the variable. So that means you got your y raised to the 4 plus 3 plus 1, and that will give us y to the 8th. And that will give us y to the 8th. Okay. All right. Okay. Yes, 0 cannot be raised to a power. Yeah, especially 0 power. Okay, you're going to get undefined because you have a 0 in the denominator. 0. Yeah, so that will be undefined. Okay, can I focus on what I need to focus on? All right, so here we go with the exponent. So then we have our 7 y to the 5th times, and I'm going to use parentheses, 6y. What is my answer? Okay. Okay. Hey, Rosette, how are you? Okay. So it's giving me my answer. What math is this? Algebra. All right, so Heather's saying 42y is 6. Michael, 42y is 6. My person out there, 42y to the 6. Agent, 42y to the 6. 42y to the 6. I think it's Sarah, 42y to the 6. Jordan Square, 42y to the 6. Thomas, y to the 6. Okay, Shelley, is that Mariah? Is saying 42y to the 6. Emerald A, 42y to the 6. Good. There we go. 42y to the 6. Rosette Rivera. Good. Marisol. Good. Okay. Addicted. Okay. Y to the 7th. So, like you guys are doing, you multiply the coefficients. So 7 times 6, that will give us 42. Now, we have y to the 5th and we have y to the 1st. Okay, so when we do this, we're going to add our y's. When you're multiplying, you add your exponents. So it will give you 42y to the 6th. Okay. So regardless if they're using the dot or they're using parentheses, you're doing the same exact thing. Okay, last one, and then we'll move to the next section. Okay. What is my answer? Okay, Jamie. Good. Is that Kara? With the 42y to the 6 for the last problem? Good job. Is the letter, it's going to be always 1? Yes. So if you just have a variable, the exponent and the leading coefficient, the number in front, unless there's a number there. If you just see a letter, it will be 1. Okay. All right. So now I have negative 15s. Let's see. Hey, Janice. How are you? All right, so Sarah is saying negative 15x cubed y to the 42nd. All right, no problem. Shushan is saying negative 15x cubed y to the 13th. Heather is saying negative 15x cubed y to the 13th, negative 15, so shadow, negative 15 y cubed y to the 13th, agent, negative 15 x y to the 15th, by Felicia, negative 15 x to the cube y to the 3rd, Amara, negative 15 x cubed y to the 13th, Luke, well, all of a sudden it just skipped on me. What did it do? I was like, Luke, what was your answer? There we go. All right, negative 15 x cubed y to the 13. Carol, negative 15 x cubed y to the 13. Negative 15 x cubed y to the 13th. All right. Zahara, negative 15 x cubed y to the 13th. Serena, negative 15 x cubed y to the 3rd. Emerald, negative 15 x cubed y to the 13th. Valencia, negative 15 x squared y to the 13th. Butu, negative 15 x cubed y to the 13th. Okay, we're starting to get some that is that. Okay. All right. Okay, so here we go. Negative 3, negative 3 and positive 5, negative 15. So we all got that part. So we have x squared and we have an x. Remember that x is going to give me 1 as my exponent. So we have x, 2 plus 1 gives me 3. Then we have our y's. We have 7 and 6. That gives me 13. Okay. So our answer is negative 15 x cubed y to the 13th. Okay, there we go. All right, awesome. Hey, Amber. How's it going? Hello, Glenn. Yeah, don't forget about the X, Glens. Don't forget about the X's. So that's the product rule. Okay, so now we're going to go into what's called the quotient rule. Okay, we're going to do a quotient rule. So for my quotient, remember quotients is basically division. So I have y to the 6 over y to the 2nd, or y squared. Now, let me show you what it looks like expanded, because sometimes people seem to understand it more other than me just saying, okay, that's the property, enjoy. No. So if I expand this, that means y to the 6th power. That means I am multiplying this base of y 6 times. Y to the 2nd power means I'm multiplying that base of y 2 times. So what's happening is I'm actually going to be doing some canceling out, because think about it. A number divided by itself always equals 1. Now, what's 1 times 1? I know I'm insulting your intelligence. Just work with me here. If I just see one person that says it, then I get it. All right. Who's going to be the first person to tell me what 1 times 1 is? Who's going to be? There you go. All right, Emerald. All right, Emerald. You've won. Admiration. There you go. Good job. All right, so 1 times 1 will give me 1. And we all know that anything times 1 is going to be itself. So this is why you cancel out and you don't have to worry about them. So now, where my little piece of magical paper go? So now you're just focusing on what's left. And what's left is going to be 4y's. And 4y's is the same as saying y to the 4th power. Okay. Now, instead of you drawing out and expanding each and every one of them, the quick pick of all this is when you have y to the 6 divided by y to the 2nd If it has the same base, which is y, you're simply subtracting the exponents. That's how we got y to the fourth. Okay, so you can expand it out. I'm going to put a little divisor here. So you can hit the expansion form, or you can just simply subtract. Okay, so do we see why you're doing when you're subtracting? When you're dividing, you're subtracting the exponents. Okay. Okay, so the reason why unique, you divided the exponents. You're not dividing the exponents. You can divide the coefficients, but you're going to subtract the exponents. Okay. All right. Awesome. Okay. All right. Thanks for the follow, guys. Let's keep this moving. So if we have, let's say 7 to the 13th power divided by 7 to the, 4th power. What's my answer? Okay, not a problem, Glenn. It's all, I know, it's all there. It's all there. Sometimes you just need to be in a quiet space, feeling supported, and just relax. There we go. All right, so let's see what we got. So we have, let me start from the beginning, maybe. Okay, Mariah saying 7 to the 9th power. Heather, 7 to the 9th power. Serena, 7 to the 9th power. Bye, Felicia, 7 to the 9th power. Abutu, 7 to the 9th power. My sister from another sister, 7 to the 9th power. LC, 7 to the 9th power. Austin, 7 to the 9th power. Michael, 7 to the 9th power. Lucas saying 1 to the 9th power. Agent of God, 7 to the 9th power. Terry, 7 to the 9th power. Sorry, I have to scroll. Okay. Neek, hey Neek, 7 to the 9th power. Jordan Square, 7 to the 9th power. Addicted, 7 to the 9th power. Tiki, 7 to the 9th power. Luke, 7 to the 9th power. Okay, Valencia, same thing. Take a look, 7 to the 9th power. It's supposed to be 1 to 9th power. Should be Esmeralda, 7 to the 9th power. Rosette, 7 to the 9th power. We're saying 7 until the exam time. It's okay, Sarah. It is. It's still going to be there. Hey, General. Okay, Marisol, 7 to the 9th power. All right. Let's see. Is it Aslina? 7 to the 9th power. Okay. Amber, 7 to the 9th power. Janie, 7 to the 9th power. I'm doing. Now, this is what happens, guys. When you're dividing, a lot of you guys got it, you're going to keep the base. So the base is still going to be the same. Okay, just like how we did with the y's, we multiplied 6 y's and we divided by 2 y's. Okay, so our base is not being divided. That's going to stay the same. But you are going to subtract the exponents. So when you have your 13 minus 4, that means you still have your base of 7, but it's going to be raised to the 9th power. Okay, so you're not doing anything with the base. Most of the work, especially if the bases are the same, most of the work is going to be with the exponents. Okay? Oh, check my bio. You love me. I don't know why you love me so much. And you always want to change your name. And it's just like, it doesn't feel right. I think it's my voice. I think check my bio just loves me. He's obsessed with me. So much that he has a picture of my butt as his profile pic. It's so lovely. It's like, enough already. Every blessed time. Like, right? He's like, why are you so obsessed with me? Little Mariah Carey in there. I was like, if you want to date, just say so. You didn't have to put my butt on there. It's kind of cool. I know. It's just the little things in life. It's kind of cool. I know. It's just the little things in life. I know. Yeah, that's when I was... Hold on. Okay. Can you guys still see me? Or is everything completely paused? Can I get a thumbs up just to make sure that you guys can still see me? Okay. Yes? Okay. Yes now? All right. Yay! See, that's what happens, Check. You mess us up. Okay. So, let's take it a step further. I have faith. So we have 10, a to the 7th. I'm waiting like towards the end. I forgot what that one guy is. He's always popping in here and talking about, I got $5,000 for the first 5 people that sign up. Dude. No one ever signs up and you still keep coming in here. I think it's me. It's that sexual attraction that just keeps zooming through the airwaves. All right. Okay. Better that. All right. Yeah, I was just seeing it was lagging. It should be okay now. Can you guys hear me and see me? Okay. All right. There we go. Okay. We should be good now. All right. So what do we have? We have 10a to the 7th, b to the 9th, divided by 15a to the 5th, b to the 9th power. Okay. So my Heather is saying 2a squared over 3. This one is tricky. It's a little tricky, but keep with the same philosophy. Now, is it Sancho is saying 5a squared? Okay, just take your time with it. And again, give yourself some opportunity to try. And after you tried, you're like, yeah, no. Then put a question mark in the chat or in the comments. Keep saying chat. Okay. So Michael's saying 2a squared divided by 3. Okay, Agent is saying 5a squared b to the 9th is the LCD. Well, we're not really adding the fractions. We're trying to simplify. So Luke is saying negative 5a cubed. Please don't waste my time. Oh, I love your name. 5a squared b to the 1st. And we're saying 2/3 raised to the 2nd. Okay. There should be some A's and some B's in there. I know, because that's my life philosophy. Don't waste my time. Just what you want. Tell it to me. Let's go. Okay. So Mimi is saying 5a squared b, right? So we got 2/3 a squared b, 2/3 a squared b to the 0 power. Now what is 0 power though? B's, double B's. Okay, you think you're doing 5 times 9 first? Okay, negative 5a squared. And you think it's 7 times 9 first? Don't B's cancel out? All right. All right. So let's take a look. Let's take a look. Because I'm getting a lovely variety of answers. And something like this always pops up on GED, ASVAB, ACCUPLACER, TEAS, HESI, just name them. Everything from A to Z, any of those assessments. Now, as I mentioned, the coefficients, which is my 10 and the 15, we could divide that. But it's not going to be divided evenly. Because, but they do have something in common. And I think a lot of you guys were telling me. So what they have in common is 5, right? So 10 divided by 5, that gives me 2. 15 divided by 5, that gives me 3. So if you guys were wondering, where are these 2/3 coming from? What's this 2/3 coming from? That's where the 2/3 is coming from. The coefficients, you basically either divide or you simplify and keep it as a fraction. Now, let's go with our A's. Let me see if I can get my other piece of paper. And then we can focus our attention on one spot at a time. So here we are. We have a to the 7th and a to the 5th. They both have the same base, so we're going to subtract. We're going to subtract the numerator's exponent minus the denominator's exponent. So we have 7 a's in the numerator, we have 5 a's in the denominator. And if we did our canceling out, we will have 2 a's. But those 2 a's are going to be where? Are they going to be n for numerator or d for denominator? Put that in the chat. So there's going to be 2 a's left. Where are they located? N for the numerator or d for the denominator? Okay, so Heather's saying n, Michael's saying the top, which is the numerator. Yep, n for the numerator, good. Miriam, good. Amber, N. Holly, N. Good. Agent, N. Mimi, N. Good. Tiki, N. There we go. David, N. Chino, David. Okay, the numerator. Good. So that means we should have, let me cancel this out. And let me cancel that out. But it's going to have 2 of those in the numerator. Sliding over with our B's. We have b to the 9th divided by b to the 9th. So if we have the same base, we add the exponents. So it's subtract the exponents. So it's 9 minus 9. That gives me 0. And what did we say? Anything raised to the 0 power gives me 1. These bad boys cancel out. And 1 times anything is going to be itself. So now let's clean this up. Let's see what we got here. We have a 2. We have an a to the 2nd power. The b's cancel out. But then we have a 3 in the denominator and we don't have anything left. This is my answer. Okay. Okay, not a problem, Roberta. Not a problem. Okay. Questions. Ask them now. Okay. All right. Well, thank you. Okay. I know, Heather. Look at you. Job, Amber. Okay. All right. Yeah, we're not even done. So save your screenshots. We got more to do. Hey, Shakira. How are you? All right. Okay. So that, when you multiply, you add the exponents. When you divide, you subtract the exponents. So now let's go to what happens when we get a negative exponent. All right, well, let's work this out. So negative exponent. So if they give it to us right off the bat, let's say 2 raised to the negative third power. Okay. I'm trying, if you haven't noticed, I'm trying to match, do a color match. Okay. So we have a negative exponent and we can't keep it that way. So the best thing, because normally when you see a whole number, it's always understood that it's being divided by 1. So in order for me to change this from a negative exponent to a positive exponent, I got to flip it. As some people would like to say, the reciprocal. So you have your 1 in the numerator, and then you have 2/3 in the denominator, but the 3 now, because the act of the flip made it positive. So now let's finish it out. We could leave it like this, but I want to finish it out. What's 2 to the third power? I want to make sure you were paying attention in the beginning. What's equivalent to 2 to the third power? There we go. Jalen, good. Esmeralda, good with the 8. Addicted, good. Jordan, careful. 2 times 2 times 2. Okay, Randy is saying it's not 2 times 3, it's 2 times 2 times 2. Okay, you probably got here a little bit later. Anytime, good. Anytime that you have is not 6. This is your exponent. It's telling you that this base is multiplying itself 3 times. Okay, so it's 2 times 2, which gives me 4, and 4 times 2, that gives me 8. Okay, and trust me, when you see it on any type of these assessments, 6 will be an option. Like 1/6 will be an option, hands down. I mean, I can bet I don't want to say bet my whole life on it, but I'll bet my 50s on it. Okay, 40s. Let's do 40s. I'll bet my 40s on it. Okay. All right. So we definitely got to make sure we get that situated. Now, for this next one, what happens if I have negative 3 raised to the negative third power? Okay. How did it get 8 again? 2 times 2 times 2, right here. It's right here. That's why we take down these notes. Okay. Yellow. Tishala, how are you? Okay, so Jordan Squared is saying 27. Okay. Purdy saying 27. I am Purdy. Okay. All right. So it's saying 27. 2 negatives make a positive. Okay. Heather is saying 1/27. Michael is saying negative 1/27. Chavez says negative 27. Mariah saying negative 1/27. Getting a nice, interesting blend of numbers. Okay. Esmeralda, negative 27. Yep. Getting right into it, girl. Calvin saying 27. Okay. Is it Abdali? Abdali saying 27. Addicted saying 27. All right. Let's take a look. All right. First off, 1. It's good that you're recognizing that the negative 3 is being raised to the negative third power. Is someone killing that bird? Jeez. All right, so my base is at negative 3, but we have a negative exponent. So that means, remember, if you just see it and it's not in a fraction form, it's really going to be over 1. So in order for us to kind of get this, first off, we got to flip it. So the 1's coming on top here. Now, the negative 3, the base is staying exactly the same. The flip is only speaking to the exponent. Okay? When you flip it, only the exponent is being negated, is being switching its sign. All right? Not the negative 3. So now we have negative 3 multiplied itself 3 times. So a negative 3 times a negative 3, that gives me a positive 9. But then we have to bring down this other negative 3. So 9 times negative 3, that would give me a negative 27 over 1. Okay, so when you dropped it, when you flipped it to the denominator, only the exponent is going to change. So it had to be a fraction, 1 over negative 3 to the third power. Then you had to figure out what negative 3 to the third power is. It is not negative 9. It's negative 3 times negative 3 times negative 3. So negative 3 times negative 3 gives me 9. And then 9 times the negative 3 gives us our negative 27. So it's 1 over negative 27, or you can say negative 1/27. Okay. How do you know when to flip? When you have a negative exponent. Okay. When you have a negative exponent, that's when you're flipping it. Okay. Mary keeps you humble. Yeah. All right. All right. Rusty old man. When can it keep you used in real life? Well, a lot of the programs that we use are stemming from exponents. In order for you to deal with higher numbers, which we want in our bank accounts and beyond, that you use with the exponents so you know what you have from what you don't have. Okay. All right. So, anytime you have a negative exponent. Now, let's say, and I'm going to try to put it right here so we can keep up with the trends of the negatives. So let me put a nice little divisor right here. There we go. Divide that up. Now, if I said 2/5 n to the negative third, what would be my answer? I saw this in one of the practice problems the other day. Yep. There you go, Heather. There you go, Michael. Don't we change? Yep, and how would you change it to positive, Randy? No, we're not multiplying 5 and 3. So when you're dealing with higher numbers, when you're dealing with Richter scales, when you're dealing with measurements, that's all exponents. You're dealing with exponents all the time. And especially if you're dealing with smaller numbers, when you're trying to do with medicine, when there's medical research, how things are growing exponentially or how it can be on decline, we're using it all the time. We're going to flip it. You forgot about those? Yes, thank you, Michael. Okay, they're only flipping what has the negative exponent. So there isn't a parenthesis around the 5 and the n to the negative third. Only the n has that negative exponent. So only the n, to change it to positive, needs to be flipped in the numerator. So that means the 2 stays right where it is. It'll be n to the third, and the 5 stays right where it is. That's your answer. How are we regular folks? Why would we want to just stay in one span? So how do you know if their calculations is correct? Okay. Addicted, what's wrong? Nope, we're not flipping the 5 and the 2. We're only flipping what has the negative exponent. The 2 and the 5 stays exactly where they are. The only thing that had to move, the only thing that was being raised to the negative exponent is your n. So that's the one that had to go to the numerator for it to change positive. Okay. All right. So the 2 and the 5 stays right where it is. Only what's being raised to the negative exponent moves. Let's try this. What would my answer for this one be? Okay, no problem, Michael. Thank you for stopping by. I appreciate you, as always. There you go. Okay, so Sancho's got 1/4 x to the negative 4th y to the 4th. I'm saying y to the 4th over 2x raised to the 4th. Oh, you mean 1/2. Okay, thank you. So 1/2 x raised to the negative 4th y to the 4th. User 4992 saying 1/3 x to the 4th y to the 4th. Butu saying 1 minus x to the 4th y to the 4th. Tashella say y to the 4th over 2x to the 4th. 1/2 as well, okay. Okay. I don't even know what that is, but we have 1/2 x to the negative 4th y. 10 toes on it. So y to the 4th divided by 2x to the 4th. Okay, y to the 4th. Albard saying y to the 4th over 2xy to the 4th. Amber saying 1/2 x to the 4th y to the 4th. And Dicta saying 2y to the 4th third, 3x to the 4th y. We got Lisa, xy to 4 divided by 2x plus 4. Okay. And then Agent of Gods, 1/2 x to the 4th, y to the 4th. All right, let's take a look. So if I'm looking at my coefficients, 3 over 6, okay, 3/6. That can be reduced, okay? It can be reduced by 3. So that means 3 divided by 3, that's a 1. And 6 divided by 3, that's a 2. This is where people are getting that 1/2 from. So now let's focus on our x's. So we have x to the 3rd divided by x to the 7th. Well, if we subtract, because this is division, if we subtract them, 3 minus 7, we get a negative 4. But with that negative 4, that's down here in the denominator. But we can't leave our answers with a negative. So that means this negative, or x to the negative 1/4, has to go up into the numerator as a positive. So this will actually be x to the 4th. Okay. Then we have our y's. Y to the 5th minus y to the 1st. If you don't see an exponent, it's going to be a 1. 5 minus 1 will give us 4. And where are those 4 y's? They're in the numerator. Because if I had 5 of the y's printed out and only have 1 y down here, if I cancel out, I got 4 y's still in the numerator. So now let's clean this up. For your numerator, what's left is your x to the 4th, y to the 4th. I know there's a 1 here, but you could put the 1, it's perfectly fine. So we have our x to the 4th, y to the 4th. So that's in the numerator. In the denominator, it's what's left. And what's left is my 2, not my 2y, just my 2. Okay. Hey, Robert. All right. So if you want to put the 1 in front of the x, you can. That's fine. But remember, if there isn't a number in front of any of the variables, it's always assumed to be a 1. Okay. Check my x's. Oh, my x's as in the x's are problematic. Oh, yeah. All the time. Finally got rid of mine, so we're good. You are good at math. What are you talking about? Jesus. Give yourself some grace. Now, how else would you write it, Agent of Gods? Okay, so if my x is, oh, you are right. Because if I do my negatives, yep, you are right. You are so right. Let me redo that again. The negative should be up here because there should be 4 x's left down here. All right. Let me scratch this. Let me start again. And that's why there's space. Okay. So we'll go here, start again. So we understand this is going to be 1. This is going to be 2. There's 3 x's here. There's 7 x's there. So this should be x to the 4th. Thank you. There's 5 y's here. There's 1 y there. So there should be 4 y's up here. So my numerator, we have y to the 4th. Denominator, 2x to the 4th. There we go. Thank you all. This is what happens when you're working on 2 hours of sleep. Love it. Okay. With the 1/2, understandable if you put the 1 up here, you can put the 1 here if you want. That will be fine. Okay. Yes, thank you, Heather. Okay. What's that? I don't know what that symbol is, Heather. Okay. The variable is not our personal lives. Okay. It does matter where you put the x's and y's. When do I go live? Almost every blessed day. Hence why I'm tired, because it takes a lot of prep to do all these things. Hence, that's why I only have 2 hours of sleep. Hi, how you doing? Okay. All right. Okay, so those were the negatives. We did the product, we did the quotient, we did the negatives. Now, let's take a moment and we are going to go to the other side. What color is this? This is blue, power of a power. Okay, so we're going into powers of a power. Now, I know there's probably some people, let me pause for a second, that are like, Audrey, I love you, but it's Saturday. I got all this other stuff I got to do. Actually, give me a moment, because if you go here, all right, and you go here, you can actually get all the replays, all right? And if you can do these 5 things, that'll be awesome. So if we can get all our replays on there, let me see if I can shrink it up for a bit. So all my replays from February the 2nd is there. So anything, if you want to see a different way of how I did exponents, is there. You know, factoring, it's there. We're still going to do factoring. I'm going to be on here for a bit. And, you know, rational functions, radical expressions, basically a lot of stuff that's going to be on the test. You can watch the replays there. All right, so you just have to go here and then type in that, do a search, and then you can go ahead and sign on in. All right, thank you, cool man. All right. Okay, oh yeah. All right, so I'm gonna take this down. 5, 4, 3, 2, 1. All right, so gives you a place to go. So now, okay, we're done with that. So now we're doing a power to a power. So if I look at this, I have x squared raised to a power of 8. Now, we could, we're saying that our base here is being multiplied to itself 8 times. So if you want to, you can do 8 squared. That's 3, 4, 5, 6, 7. I'm gonna 8. Okay. 3, 4, 5, 6, 7, 8. Okay, so we have that base of x squared being multiplied to itself. You see how tedious this is? Well, this is what they used to do back in the day. That's what happens when you have an old teacher. All right. So it's everything that's inside the parenthesis is multiplying itself 8 times. So when we're multiplying, remember, we add our exponents. So you got 2 plus 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 2, right? Or what we could say, it's really going to be 2 times 8. Because remember, multiplication is nothing but fast addition. So we're going to keep that philosophy going for this problem, which gives me x raised to the 16th power. Okay, it's going to be raised to the 16th power. Okay, 2 plus 2, that's 4, plus 2, 6, 8, 10, 12, 14, 16. Okay. So instead of you expanding it out like this, because who has time? No, we're not doing that. All you're basically doing is when you see an exponent being separated by a parenthesis and raised by an exponent, you are multiplying your exponents. Okay. Do you see the difference? Okay. Hey, Lynette. Good morning. Good morning, Angela. How are you? Okay. All right. So this is what's happening. All right. Thank you for follows. So if I take it to another bit, I'm curious to see what would you guys get with this answer or this problem. What's my answer? Oh, good. Okay, I got Y. I got Black Betty Boo saying 12. Robert saying Y to the 12. Heather, Y to the 12. My Go saying Y to the 12. Loud is saying Y to the 12. Jordan Square, Y to the 12. Janie, Y to the 12. Okay. Embry, Y to the 12. Okay. I know for just a second you saw the negatives. Good, Addicted, Y to the 12. Okay, Angela, Y to the 12. Melanated Fishing, Y to the 12. Good. Okay. I know for a second you saw the negatives and you're like, okay, I got to flip. But remember, we have a negative being raised by a negative. A negative times a negative give me positive. So those rules of integers and signs, that still applies. Okay? We're never just learning it once and then we're done. So we have, in this situation, we have y raised to the negative third times the negative fourth. So negative times negative, that will give me positive. And then 3 times 4 will give me 12. Okay? You see why it's not just y? We're not subtracting. We're multiplying. We subtract when we divide. You see why it's not just y? We're not subtracting. We're multiplying. We subtract when we divide our integers, but when we have a power being raised to a power, we multiply them. Okay? All right. Thanks so much for the love. I mean, it's basically it. So if we have next one, it's in black. So the next one, we have parenthesis. We have 4 times x cubed y z raised to the 3rd power. And you're like, say what? So this, in this case, is called the power of a product. Because what's happening inside the parentheses is nothing but multiplication. Okay, you got 4 times x cubed times y times z. But everything inside the parenthesis is being raised to the 3rd power. So this is telling me that my 4 is being raised to the 3rd power. That means my x cubed is being raised to the 3rd power. My y is being raised to the 3rd power, as well as the z, or z, depending where you're from, to the 3rd power. Okay, so everything inside that parenthesis, including the coefficient. So many people lose points because of that. Okay, and all of a sudden when they hear about that, like, oh, I wish I knew. Now you know, so there's no excuse. All right, so now, what's 4 to the 3rd power? What's 4 to the 3rd power? And don't say 12. I will shut this off. Do not tempt me. Think about it. Think about what we've been saying. Okay.